This is number 53 in dynamics, and we've got a ramp, and we're going to take a block, and we're going to throw it, slide it up the ramp with a VI of, I believe it's 3 meters per second. And the question is, how far up the plane will it go? Okay, so there's a couple of different ways you can do this, and there's no friction on the ramp. Okay, this would be quite different if there was, but there's no friction. So what we want to do really is find the acceleration. That's our big key here. We know the VI, the VF at the top is going to be 0, and we'll be able to find the distance, how far it goes up, if we have the acceleration. So what's the acceleration? Well, it's not 9.81 because this is a ramp, right? So you have gravity down in this case. This is mg, and you have normal out. And this component of gravity is negated by the normal, and this downhill one, I shouldn't have written this on this side, sorry. That's mg. This component here, so messy. This is what I would call FGX, which is equal to mg sine of theta. That's the downhill component of gravity. Okay. And that's going to be this will be the net force because there's no friction pulling back on us. As soon as you let go of that block, you're only going to have the downhill component of gravity, and so that will be the net force. There's just no other forces acting. This normal force is negated by the y component of gravity, and the x component is pulling downhill. So we can say that ma equals mg sine theta. We can get rid of those m's nicely, and so my acceleration is g sine theta. And so we can calculate that. And we can say 9.81 times the sine of 22, I think it was. And that's going to give us 3.67, which makes pretty good sense. And that would be meters per second squared. Once you have this, it's pretty simple kinematics problem, right? We're just going to use that second formula. And we're going to solve it for d, so we're going to say vf squared minus vi squared over 2a is equal to d. And so for us, that's 0 minus this number. So I just kept that in my calculator. We square it, and then we divide by 2, and then we divide by, oh wait, sorry, I did this wrong. Our vi is 3. That was our 3. So we do 3 squared. So 9 divided by 2 and divided by our acceleration, 3.67, we'll put that in there. And we come up with about 1.22. So we do, this is, and that equals about 1.23 meters or so, which should be the distance up the ramp. We go. Oh, wait a minute, there's a B part to that, isn't there? The B says how much time elapses before it returns to its starting point. Ignore friction. Okay, so if you do B here, we know now the distance, we know both the velocities, we know our acceleration. We can just use VF equals VI plus AT, and we can do it this way to find time. Now, you have a choice here. You can say VF is 0. That will tell you how long. So if the thing goes up and comes around and it like stops at the top and slides back down, you could say that VF is -3, and that's kind of generally what I would do. I would say -3 minus 3 over my acceleration, which is going to be, this really should really be negative 3.67. I should put that negative in here too. It's a negative and negative, so that's going to be positive. And so that's going to be -6 over -3.67. And you're going to get about 1.63 seconds. Now, you could also say VF is 0. You would end up with half this time, and that would be the time it would take to get to the top. And then you would just double that time.